Hello guys, so here we are back. So that just like the last time I had promised that I am going to solve GFG and LeetCode daily together on live stream. So here I am. So let's head to the problem of the GFG, remove duplicate elements from sorted linked list. Though the problem is very clear from its name itself, we have to remove the duplicate element. Oh, I have already solved it in the past. No issues, we will reset the code. We have to remove the duplicate elements, like in this linked list we can see we have 2 2 4 4 5 and we have to return 2 4 5. It's an easy level question, I think basic level, so we just have to play with a little with pointers. So we will first, what will be our approach? We will first iterate to the linked list and we will check the neighboring adjacent two elements, and whenever we find two same elements we will change the pointer of the first element pointing towards the next element's next, like it would be node dot next equals to node dot next. In this case we will arrive at this position when we are at the second node. So then we will at the first node. So our linked list will be like this. When we acquire the first node, we will say that these two elements are same, and it will be shifted to 2 will be pointed to 4, right, by using this condition. So I hope the approach is quite clear, and let's code it, right? So while head dot, let's store it somewhere. Let's store the head. Okay, we are storing it in node. Now while head dot next is not equal to none, if head dot data equals to head dot next dot data, what we will do, we will change the pointers. We will shift the pointer pointing to the next element to the next to next. So in this case we will shift the pointer pointing towards 2 from 2 to 4, and then this way we will omit the 2 and we will have all unique elements. If that wasn't the case, we will keep iterating the list, right? Now we will return if head dot data. Okay, sorry, I miss a equal to sign. Here is our answer. Submitting it. Tada! I also have a second approach for this question in my mind. Like, this second approach is that we will constitute a list, okay, and we will append all the elements of the linked list and then convert the linked list into, append all the elements to the linked list and then convert the list into a set, or in some way we will eradicate all the duplicate elements and then reconvert the list into linked list, so we will have all unique elements, right? So let's do that. So we have a list. So while head is not null, L dot append head dot data, right? And head equals to head dot next. Okay. Now, in order to remove duplicate elements from any list, we know we have to convert the list into the set and reconvert into list. So we are going to do the same, list set L. So we convert the list into set, then list into set. Okay. Now we will have two nodes, N1 and N2. These we will use to reconvert our non-unique list into linked list. So for x in array, n1 equals to node x, n1 equals to n1 dot next, return n2 dot next. Cool. So let's run it. We are not getting our desired output. Why? It's always same. You know, we have implemented this sort of approach in many processes. Like there are processes in which we have to the process in which we have a very complex. You have seen in Strava sheet that we have a linked list, and to each node there is another linked list attached, and we have to convert into a single linked list. We have also used that approach there. I don't know why it is not working. Let's try this way. Try in range. I hope this will work. No, this is also not working. I think the problem is in the array one. Maybe we are not able to remove all the duplicate elements. I don't know why, because in general cases we used to remove the duplicate elements from a list in this way. Never mind, I couldn't understand where I am going wrong, but we have solved today's GFG. But I want to solve this way also, because this way is easy and very much intuitive. You know, you may, while solving, if you are out of touch, you may not come with the pointer approach, but this approach is quite intuitive, and you can get through the interval. Maybe the interval say no, this is not the optimized approach, but still you have done something. It works in most of the cases. I think this is where we are getting wrong. We are not able to remove all the duplicates from the list. I didn't get any way why I am doing this wrong, because in usually such type of question this works. So if you have any slight of idea why it isn't working, where I am going wrong, please tell me in the chats. Okay, now without wasting any further time, let's move to today's LeetCode question. Implement using stack. I forget to do the yesterday's LeetCode question because first thing, it is too difficult. There is no video to guide you through, and I have some work to do, so I had to miss today's LeetCode. This question is also already I have also solved it, right? So cool, it would be easier. Okay, so what we have to do? So we have given a implement stack using LeetCode stack using only 2 queues. We have to implement it using 2 queues. Thus, should we support all functions? Blah 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 blah. In simple words, we have to implement the stack using 2 queues. We know why we have been given this, because stack is a LeetCode structure. Last in first out, and queue is a FIFO structure. First in first out. So let's implement it. This is first measure we have to implement is that we have to initiate the stack. I think it's going to be easy. We just have to initiate the queues. So we will just import collection.dq, spelling of dq. So we self dot we forget to initiate. I think this is not the way. We have to initiate it. So we have to initiate a variable for storing a queue. Okay, so I forget it. Self.queue collection.dq, and now we just have to append the element self.queue dot append x. Popping is a little difficult, so we will left it for the last later. We will do it in the last. Now we have to see the top element. I think it is also same. We just have to give the last element which we can access using the negative index in Python. So it is not also difficult. Return self.queue -1, right? Now here we will have to check the empty, whether the stack using queue is empty or not. So I think it is also very same. We just have to check the length. If the length of the queues we are using is 0, so the our stack is also empty, otherwise okay. So this is also very same. Return length self.queue equals to 0. If it is 0, it will return 2, otherwise false. The most difficult part, I think the most difficult method to implement is this of pop method, because it's quite tricky. Because in stack, when we pop the element, we pop the, using LeetCode principle, we pop the topmost or last in element, and in queue we always pop the first element. So I think in all these methods except pop, we only required only one queue. In the pop method, we need two queues. That's why they had asked us to implement using stack using two queues. What will you approach? We will have a stack. We will have a queue, queue, where we will store all elements except the elements that need to be popped, and the element that need to be popped will be stored in another queue. So what we are doing is just we are doing a transfer of elements from Q1 to Q2 of all the elements that are not required to be popped by using pop left. Okay, and after this is done, Q1 has the element needed to be popped, and we will pop it using pop left function, right? So for this method we need two queues. So I hope the approach is clear. It is simple. We will have two queues. In one queue, we have Q1 where we have all the elements. We will pop each element one by one from the left part and store it into the another queue until unless in Q1 we have left with only one element, the element that needs to be popped out actually for this method, and we have all the elements required in Q2. After we popped the element in the Q1, we will again go through and Q2 will take the position of Q1 for all the respective methods. Okay, so now without wasting any time, let's implement this. So for I in range len self dot q minus 1. Why minus 1? Because we don't have to store the last element of the Q1 into the Q2, because it is the element that needs to be popped. You know, stack's principle, last element to be popped. So we will store rest all other elements in another queue. Self dot push self dot q dot pop left. We are using pop left. Even if you don't use pop left or you use I, that self.q.I, both works equally. It's my just personal choice. It's easier because to demonstrate the what we are doing, we are removing first elements and then we are storing it in the same order that they are stored in the Q1. Okay. After we have removed all the elements, we will be returning self.q.pop left, the last element that needs to be popped. Okay, I hope this is all about the code. Let's run it. Collection, it is, I think, collections, not collections. I always made this mistake. The code runs. We are two queues for any of the method. It is the pop method we require queues and we use them efficiently. So that's about it. Now submit it. That's it. It is running. It is submitted. It is accepted. So today it's a lucky day. Both GFG and LeetCode had easy level questions. So I have improved in streaming, but I know it is not that up to that level. So I will work on improving the quality of streaming. This will be better tomorrow, right? It will improve. So what we have today, we have two things to do. First, you will tell me where I am going wrong in the second approach of GFG POTD linked list one. In the one we are using list to remove the duplicate elements. I still didn't get it, and you got this. See you all tomorrow. Bye.